Have you ever wondered why, when it's daytime where you are, it might be nighttime on the other side of the world? This difference in time is a fundamental aspect of living on a spherical planet that is constantly in motion. It's why we need time zones. Our planet, Earth, is a sphere that spins on its axis. This spinning motion is called rotation. One complete rotation takes approximately 24 hours. As the Earth rotates, different parts of its surface face towards or away from the Sun. The side facing the Sun experiences daylight, while the side facing away is in darkness, experiencing night. This continuous rotation means that the Sun appears to rise in the east, move across the sky, and set in the west. This apparent movement is the basis for our concept of a day. For centuries, people used local solar time. Noon was simply when the sun reached its highest point in the sky at their specific location. This worked well when travel was slow and communication was limited. However, with the advent of faster transportation like trains and the invention of the telegraph, coordinating activities across different locations became essential. Imagine trying to schedule a train arrival if every town along the route had a slightly different time based on its local sun position. A standardized system was needed. This led to the development of time zones. The goal was to divide the world into regions that would share the same standard time. The system is based on longitude, the imaginary lines that run from the North Pole to the South Pole. There are 360 degrees of longitude around the Earth. Since the Earth rotates 360 degrees in about 24 hours, it rotates approximately 15 degrees every hour. This calculation is key to understanding time zones. The world was divided into 24 primary time zones, each roughly 15 degrees of longitude wide. Within each zone, everyone agrees to set their clocks to the same standard time. The starting point for measuring longitude and time zones is the prime meridian. This is an imaginary line that passes through Greenwich, London, in the United Kingdom. The time at the prime meridian is historically known as Greenwich Mean Time, or GMT. Today, the standard reference time is Coordinated Universal Time, or UTC, which is closely related to GMT. Time zones are measured as offsets from UTC. For example, a time zone might be UTC plus 1, meaning it is 1 hour ahead of UTC, or UTC 5, meaning it is 5 hours behind UTC. As you travel east from the prime meridian, time gets later. For every 15 degrees of longitude you travel east, you generally add 1 hour. Conversely, as you travel west from the prime meridian, time gets earlier. For every 15 degrees of longitude you travel west, you generally subtract 1 hour. This system allows for a consistent time within a region, making scheduling and communication much simpler across vast distances. Most countries adopt time zones that align with these 15-degree segments, though some adjust their boundaries for political or geographical reasons. There are also half-hour or even quarter-hour time zones in some parts of the world, adding a bit more complexity to the global time map. On the opposite side of the world from the prime meridian, roughly along the 180-degree line of longitude, is the international date line. This is where the calendar day changes. Crossing the international date line from west to east means you subtract a day. Crossing from east to west means you add a day. This prevents confusion about the date as you travel around the globe. Time zones are a human invention, a practical solution to the challenge of coordinating activities on a rotating planet. They are essential for global commerce, travel, broadcasting, and countless other aspects of modern life. Let's try a quick activity to see how time zones work in practice. Imagine it is 12 p.m. noon in London, which is in the UTC plus 0 time zone. What time would it be in New York City, which is in the UTC 5 time zone? Since New York is 5 hours behind UTC, you subtract 5 hours from London's time. 12 p.m. minus 5 hours is 7 a.m., so when it's noon in London, it's 7 a.m. in New York. Now let's consider Tokyo, Japan, which is in the UTC plus 9 time zone. Tokyo is 9 hours ahead of UTC. To find the time in Tokyo, you add 9 hours to London's time. 12 p.m. plus 9 hours is 9 p.m. So, when it's noon in London, it's 7 a.m. in New York and 9 p.m. in Tokyo. This simple example shows the significant time differences across the globe due to time zones. Understanding time zones helps us make sense of global events, communicate effectively with people in different parts of the world, and appreciate the dynamics of our rotating Earth. They are a fundamental part of our interconnected world.